Welcome everyone to All Data Any AI Integration Innovations with FME and Google. Today I have the pleasure of being joined by 4 different presenters, including a couple very special guest speakers from both Google and our partner Avineon Tensing. To kick us off here, I will pass things over to Don to introduce himself.
Yeah, so my name's Don Murray, and I've been here since the dawn of Safe Software, as a co-op student said once, and so I'll go with that. And I'm really excited to be here, work with such amazing people at Safe and partners and customers. And with that, I'll hand it off to Christian Berger.
My name's Chris. I'm the leader of the customer solutions team here at Safe Software, and I've had my hand in a lot of the AI stuff. So if you watch any of the previous AI webinars, you've likely seen my face at this point, but great to see you all here, and hopefully you walk away with something that you've learned. Oliver, go for it.
Thanks, Christian. Really happy to be here. So I'm the business director in the UK for Avineon Tensing, and fortunate enough that one of our current customers has allowed us to share a really nice story with you today about how we've applied FME and some generative AI tasks. So looking forward to sharing that with you shortly.
Okay, and now I'm going to hand it off to Josh from Google.
Thanks, Don. My name's Josh Venman. I'm a geodata engineer at Google, working on the Google Maps team. Looking forward to participating in this webinar around Gemini AI and FME.
All right, excellent. Thank you so much, everyone. Just briefly here before we dive into the webinar today, if you are newer to our platform Livestorm, I just want to walk you through a few quick pointers. So if you have any audio issues during the webinar, you can click that help button on the bottom left for 4 simple steps to take. You can share your emoji reactions with us as we go through here with that react button on the bottom middle. We will have the opportunity for questions at the end. So please, we encourage you, if you have any questions at all during the webinar, please drop those in the questions tab on the bottom right. And then also keep letting us know where you're tuning in from in the chat. We love to see where everyone's joining us from. And the peak of data and AI this May 6th to 8th, coming to Seattle, Washington. Very exciting.
Yeah. And Oliver will be there. He and Christian will be there, and you might even see them both on the main stage. You just never know what could happen. So it's going to be a lot of fun, and we're really excited to do it in Seattle this year.
Yeah, fantastic. And I also just saw a communication go out that early bird pricing has been extended. So definitely take advantage of that as well. All right, so from here, I will prompt our presenters to turn off their webcams just to save on some bandwidth, and we'll pop back on for each individual presenter as we go through here. And I'll pass things over to Dawn for our agenda.
Great, yeah, so welcome everybody, really excited. I'll do a quick introduction just for a few minutes to set the stage. And then we'll hand it over to Josh at Google, who's going to talk about how they use various features of FME to help them build Google Maps. So he's going to talk a lot about that. And then we're going to dive into some real world results with FME and Gemini. So we'll have Christian Berger, who's going to talk about Agentic AI and schema mapping, how you can use it to do schema mapping across data sets that don't have the exact same schema, but they have the same data. And then we'll talk a little bit about why we're excited about Google Gemini. At this point, Oliver's really going to run with it, and has an amazing UK power network story. And then we'll talk about some hub transformers that are out there. And then Oliver's going to share a skills booster workshop, which we're really excited about. So to help all of you who are watching, to recommend you sign up and learn to do what Oliver is showing. And then Elizabeth and I are going to close it out. Okay, so let's dive into the introduction. So today, just to set the highest level, we have 2 exciting things we're really going to show you. One is we feel really happy and privileged that Google would share how they're leveraging FME to manage their spatial data at scale. Google Maps is around the world, so there's no organization that has to manage data at scale like Google, and they're going to share with us. And then the second part is really embracing, showing how with FME and our Any AI, here we're going to highlight Gemini AI and really drive home the strengths of it, the benefits of it. And Oliver and Christian are going to show some amazing things that you can do with FME and Gemini AI. Yeah, so our platform is the only all data any AI platform. And what we mean by that is it doesn't matter what kind of data you want to work with or what AI you want to embrace, or maybe you want to embrace multiple data sets and multiple AI at the same time, you can do it. The platform is really simple, consists of 2 components. FME Form, where you author all the low-level data manipulation, and then FME Flow, where you deploy it. And you're going to see in the Google case, they deploy it in a number of ways. One is high-velocity data streams, and the other is automations. And of course, there's many others. And they also use FME Flow hosted, and they're going to talk about that, which is a SaaS version of FME Flow. Yeah, and data formats, we support them all. So if there's a data type that you want, I'm sure we support it. For example, I'm just looking for one that's not on this chart, graph. We support graph databases like Neo4j. So, and we're constantly adding more. And of course, we're driven by you, our user community. So if you see a data type that you want us to support that we don't, reach out to us. And we have a big team that is constantly adding different modes and different types of data all the time. And this is what we love to do. Okay, and with that, I'm going to hand it off to Josh at Google, who's going to share how they're using FME within Google. Take it away, Josh.
Thank you, Don. So with the time I've got, I want to explain a little bit about the challenge we face mapping the world, why FME plays an important part in that, and then walk you through 3 examples of how we're using FME in our world. First of all, the challenge. As you can imagine, mapping the whole world at great detail is a complicated business. You can see from the screenshots here that we do have a lot of data for everywhere in the world. It could be street view, it could be public transit data, points of interest, public parks, waterways, roads. All of that data has got to be maintained for all parts of the planet. And it's also a moving target in that data is not static. So we're always looking for freshness in the map. Some of that data Google derives by flying aeroplanes or driving street view cars and artificial intelligence. But we also get a lot of data from authoritative sources like government agencies. And we also get an awful lot of input from individuals generating new content for the map and updates to it. And really our goal in all of this activity is to create the most useful, trusted map representation of the world, the 2 billion plus users who use the application. To give you an idea of the breadth and types of data that we're dealing with in this supply chain from outside of Google into Google Maps, these are some examples of data that we have to deal with. We've got traditional vector data, points, lines, and polygons, so address points, linear features like roads, and polygons like parks, waterways, administrative boundaries, all the way up to fast-moving data like near real-time data. I'll show you an example of that shortly. And finally, raster data, imagery that comes in from our partners. Where my team fits is right out the front of that supply chain, that production line, where we're dealing with the tools, the automation, and the human operators who take data from the outside world and transform it into our world model to make it useful in maps. And before we depart from that, a shameless plug with Don's blessing for how, if you want to get your authoritative data into maps, here's how you do it. So we operate a program called Google Maps Content Partners, the link on this slide, and we welcome your participation in the program. And there's an idea here of the types of organizations that we partner with already here, but we welcome your contact on that front. Why GIS inside of Google and why FME? For all those data types I showed you, we have an internal representation of that in our world model. So obviously we'd like all data to look like that, but it definitely doesn't. So there's no guarantee we're going to receive data in the format we desire. So there's a constant need to map from somebody else's schema and data model to our own. And we want to do as much of that automatically as we can, but some decisions really have to be made by humans. But humans using smart tools to help them make the best decision. Google has thousands of engineers who could probably build anything, but building out GIS tools isn't our core business. So we reach for best-of-breed GIS data integration tools where appropriate, and FME is definitely appropriate in this case. Gives us enormous power to transform data and be a bridge between different systems. How we're using FME is in two fundamental ways. We use it externally in the form of FME Flow hosted, where FME Flow is acting as a bridge between selected external partners and the point of entry into Google. So it gives us an opportunity to deal with idiosyncrasies of a particular provider's platform to get the data in the first place, and the opportunity to transfer it on route to our internal systems to try and massage it into a more digestible form. We also use FME Flow internally on completely disconnected systems, currently running on Windows VMs in GCE, but we're in the process of migrating to FME Flow on Kubernetes. Internally, there's a different focus, and that focus is integrating FME Flow with internal APIs and other systems. So less of a transformational piece, more of an integration piece. And all of that kind of folds into using more generic GCP services. So an example being we use GCS storage for a lot of our file persistence, and we use GCP uptime checks to keep track of what's going on in our FME Flow instances. Then on the desktop, we do have a combination of FME Form directly from SAFE and IHS data interoperability. It's all FME, but we have different use cases where it makes more sense to use one or the other. So that's our environment. So let me walk you through three distinct examples of what we're doing with FME. So the first one is an example of a fast-moving real-time data source where we're using FME Flow hosted to authenticate with an external partner, retrieve data from a WebSocket in this case, and then handle the transformation of that data into a form where we can ingest it internally. In this case, the data happens to be status updates on charging ports on individual EV charging stations across a European country. So it's a lot of data coming in every minute. So fairly fast pace. And what makes FME Flow really attractive here is a couple of things. If you think about the workbench involved here, the WebSocket connector makes light work on maintaining the connection with the partner's WebSocket and getting data and keeping the connection alive. That saves us a lot of time. As the data comes from that socket, we have some very specific requirements for handling errors. And it's less about whether we see a particular kind of error in this case. It's more how often we see a particular kind of error. So in this case, some of the temporal transformers within FME really help us out. So we're using a combination of time windower to batch groups of errors into an epoch, a time frame, the feature holder to allow us to bucket them together, and then we use statistics to figure out how many we got in that time frame, and that works really well. We wrap that whole workbench in a stream inside of FME Flow, and that gives us a really easy way of keeping that workbench running all the time. And then we monitor that stream using GCP uptime services. So that's been a really effective use of FME Flow. The second example brings us inside of Google, where we're using FME Flow in that disconnected sense, but we're still connected to all of our internal services. So here we're using FME Flow to retrieve data from internal Google APIs. And the context here is a human operator who wants to be able to get contextual information about what we have in our world model to compare with data they have in front of them from an external provider. So we need to reach into an internal API, pull back the data, transform it, and turn it into a layer in a map in front of that user. We get to use FME Flow apps to provide a simple UX to the user, so they can just draw an extent and they get fastest parameter and drives the internal API to pull the right data. The HTTP caller makes light of the call out to our API, and any pagination that's going on is handled in a custom transformer. That works well. And then probably one of the less kind of sexy transformers in the toolkit, but a JSON fragmenter is really simple way of busting that payload from the API back out into the individual features with a single JSON query. That saves so much time. And then when we want to do very specific things, we use the Python caller to, for example, in this case, enrich features to calculate directionality on them. And then finally, we use the data download service and the email it, send an email to the operator and say, hey, the data is ready. Here it is. You can load it straight away. The final example I want to talk through is less really about what FME is doing, but how we're interacting with FME. And in this scenario, it's something that happens all the time for us. Data comes in, winds up in some data store. And what we want to do is trigger FME flow to pick up that data, perform some processing, and deliver it to the desired destination, which could be back in the same data store or onto some other system. The way we're achieving that is we use Google Cloud Storage buckets to take the initial input of the data, so a file lands in the bucket. That bucket can either through PubSub, GCP PubSub, or a Cloud Run function call on a flow automation webhook to then signal whatever activity we want to happen inside FME flow. And that's a really simple to understand mechanism, a reliable mechanism for us to take action as data arrives. That's proven to be a very successful implementation. So where we're headed next, everything we do in my team is focused on improving efficiency and quality of the data pipelines that we use to pull in data from the outside world on the way to Google Maps. So we're trying to minimize the time spent in front of humans to make decisions and perform tasks that could be automated, maximize as much automation as we can, and then also take advantage of what AI can offer us in terms of doing some of the grunt work that would have traditionally had to be done by hand, or decisions even being made by AI that would be traditionally being made by humans. Some of the areas we're looking at there, and Chris is going to be talking about this in more detail, is looking at the problem I identified earlier on of the provider's data schema and the way they represent their values in their rows of data. It's very different to ours. We're looking at using Gemini to smooth that path. We're looking at it to help us with quality and consistency checking and change detection. And that's a really exciting area of development that we're spending quite a bit of time on at the moment. And with that, I'll hand over to Tom.
Awesome. And yeah, so thank you so much, Josh. That was absolutely great. The things you're using in FME Flow that you touched on were streams and automations and FME Flow app. So that was really great. And Josh alluded to something that he and Chris are looking at on how to use Gemini to even take it to the next level. And with that, I'm going to pass this off to Chris.
All right, let's take a look at Agentic AI schema mapping. So as Josh has mentioned there, this is a use case that Google is looking at using FME and Google Gemini for, of course. So overall, what happens is FME is very flexible with dynamic workflows, but there's also a challenge with receiving data sets with variable schemas. So if you're receiving a data set with schema A from one data provider, and you have a second data provider who's providing you with a completely different schema, how do you actually prepare those so that you can make them use downstream for other operations? So this is where FME really comes in here. So regardless of the file that is being received, FME can accept that, read it in, and push it to Gemini so Gemini can do the heavy lifting and perform the schema mapping. From there, we can get an output that's standardized and allow that to be used downstream for, again, other operations. So the main challenge that we're looking at here is really schema variability. As I mentioned, you could have multiple data providers providing various schemas. You can see on the right-hand side of the screen there, the same data sets can be provided with 3 different types of schemas. So we have different attribute names containing different bits of information. In this case, it's all address information. Some are concatenated into one single attribute, like you can see on the bottom. Some are parsed into individual attributes and contained as separate entities, just as you can see on the top. Some are a bit of a hybrid, so that's what that middle one shows there as well. The main challenge with this is it is an extremely manual and time-consuming process if someone was to go through and make all of these edits. But fortunately, this is where Gemini and AI services can really speed up this process. So what we're looking for here is that we're going to leverage Gemini to provide those 3 data sets to it and get one standardized output. And this is where AI processing really comes in handy. So even with the generic models that you're able to access today, you can get a good output like this. You, of course, can fine tune and train your own models if needed, but generally speaking, with Gemini's capabilities right now and the massive context window, you're able to provide large data sets and get very good results back. So again, the output that we're looking for here is standardized attributes in a data set that we can use for downstream operations, just making things a lot more predictable, which is very important for data integration workflows. One of the key things that makes this possible is using structured outputs. And of course, Google Gemini supports that. So I'm giving a little bit of a teaser here that the 2 keys of this whole workspace and this entire automation for that matter is using the Google Gemini connector to actually provide the data and allow Gemini to do the heavy lifting. And the second bit is a feature of Google Gemini, and that would be structured outputs. Structured outputs allow you to define the JSON, and that allows you to specify what schema you expect to receive back from the AI model, which again, this really helps with data integration and predictability because you know exactly what attributes will be coming back from the model instead of getting potentially random results back. It's consistent, it's always going to be in the same schema, and this is where you can make actionable items on downstream for further operations. So moving into our demo, of course, the goal here will be to transform the provided data from various providers into a standardized structured output. Again, the blocker here is that all 3 of these providers are using different schemas. So we're going to use AI to resolve that and, of course, allow this to run freely in our organization. So we'll take a look at the demo at this point. I'm going to hop into FME Flow, and what I've set this up as is just an automation where I'm watching a directory. In this case, it's a local directory on my FME Flow hosted. This could also be an FTP site or any of the other various triggers that we support on the FME Flow automations platform. And so I'm going to drag in a GeoJSON file into this spatial folder. So I'm watching 2 separate folders, one for spatial data providers and also one for tabular data providers. So I have a CSV file and a GeoJSON file. They have slightly similar information in them. And what's going to happen as soon as that file is dragged in there is it's going to kick off this automation to execute. And automation is essentially waiting for files to arrive. Again, there are various triggers that you can wait and receive. You could have a simple schedule running. You could be watching an FTP site, an Amazon S3 bucket perhaps, or even using webhooks to kick off automations as well. So what's going to happen here is as soon as that file arrives, it's going to start this process. And you might have seen those numbers have changed already. We're simply going to log that information and determine whether we need to run a spatial dynamic schema mapping workflow, again, using that Agentic AI use case, or tabular. So that's why we're watching those 2 separate folders. By now, I can switch over to the output folder. And if I give this a refresh, we can see that I have 2 new files that were just created. And this is for the spatial data as well as the tabular data. So we're getting it again in a very consistent and predictable output. What this actually looks like in real life is the outputs that we're receiving are just a standardized JSON file that, again, can be used for downstream consumption with a standardized attribute schema mapping. So we always have street address, locality, administrative area, country, and postal code. And that'll be consistent across spatial as well as tabular data sets. So this is just the tabular one for reference. It's a CSV file. The whole thing that powers this is just one simple workspace where we're simply just reading in the file that was submitted. And this is where you create your workflows in FME form before you publish it to FME Flow and allow it to run in an automation. What we're doing overall here is just reading the file that was submitted to that resources folder or to the FTP site. We're creating it, converting it rather into a CSV file so that we can send the plain text to Gemini, and that would be happening over here. And in Google Gemini, we're simply providing all of the data along with the schema and prompting it to say, we're your data integration specialist. We need you to standardize this data using this structured output as an example. The Google Gemini connector, along with some of our other AI connectors, now support the structured outputs. And this is where you can define the JSON structure for this. This is something that is extremely helpful to do in the Google Vertex AI platform because they have some examples of structured outputs that you can use, copy and paste into here, and of course, change the schema to meet your own requirements as well. So I'll go back into the slides at this point, and we'll kind of go over a little bit of a recap. So a couple of the key benefits here are, of course, efficiency and accuracy. This is no longer going to be a manual process. It's something that is extremely predictable, and you know you're going to get great results coming back every time, regardless if you fine-tuned your own model or if you're using one of the generic models. Scalability is also a big thing too. Imagine how many staff members you'd have to employ to complete a process like this, especially in an organization like Google, who's receiving data from organizations around the world. So this is a very cost-effective approach, not to say that you're replacing a human's job, but this is just supplementing their job and allowing them to work with other high-value processes instead of manual, tedious tasks like this. So what's in the future for AI in data integration pipelines? Of course, AI agents are going to further enhance automation and scalability. Of course, we just saw how this is one of the simple examples using data that you're ingesting from various providers. But there are tons of other ideas, and we've given a little teaser into what's coming with the FME UC later this year. This is where Tensing and is also going to be putting on a course on AI content as well. So they'll introduce you to more details about how to get started with AI and FME. And of course, as Don mentioned, we'll be talking more about this in the plenary too. So definitely check out the UC if you aren't signed up already, as well as our future webinars. Obviously, AI is an emerging space, so there are going to be new technologies and capabilities that are released. And as the FME platform evolves, we can supplement those with any AI that is supported right now. So it's something that is also possible. And of course, it's just going to make creating these data integration pipelines even smarter and more intuitive down the line. So where can you get started with this? Leverage your AI agents in your workflows. Download all of the latest AI connectors, so things like the Google Gemini connector. We're currently on V3 for this. Take a look at our Getting Started with JSON tutorials. If you're not familiar with JSON, this will be extremely helpful for creating your structured outputs as well as how to handle them, so flatten and fragment the results. As well, look into the Vertex Studio. This will be a great help and save you a bunch of time to get your output formats started. There's another nice tip on the bottom here. You can also use Gemini to generate the JSON structure for you if you don't have to do that manually. And with that, I'll hand things over to Oliver.
Thank you very much, Christian. That's really an excellent and helpful intro into some of the points that I raise shortly. No, thank you very much for having me. And it's actually a really exciting topic. There's an awful lot to be excited about actually utilizing Google Gemini with FME. Allow me to elaborate on that a little bit. Google has a range of large language models under its Gemini suite that it terms Flash. So these are typically smaller models that are designed to undertake slightly simpler tasks, if that makes sense. The one that really caught our eye a couple of months ago is the Gemini 1.5 Flash 8 billion, which maybe needs a little bit of a shorter name, but there's a number of reasons why it's very powerful, and the kind of spec sheet helps to explain why, but there's a lot to process here. So let's just run through those step by step. So the first one is the capability of the model to be able to ingest not only text, but images and video and audio as well. So you could, for example, give it a picture of the lizard and ask it what it's wearing and get a pretty decent response back from it. As well as that, building on what Christian mentioned, it's got a very large input token limit. But what does that mean? The capacity of many Gemini models is 1 million tokens or more. And now a token, for those of you who aren't familiar, is about 4 English characters. So 100 tokens, about 60 to 80 words. So the input token limit for the Gemini Flash model being 1 million tokens is the equivalent of about 6 books. But as I mentioned, it's also multimodal. So you can actually pass in those images, videos, and audio as well. And the standard token number for an image is 258 tokens. So that equates to, well over 3,500 images if you wanted to put into a single prompt. And equally on the output size, typically you don't usually want a large volume of output, but 6,000 words is actually quite considerable as well. The other thing that's really quite important is all to do with rate limits. So there's 2 components here under the pay-as-you-go section, so the paid-for usage of the model. 4,000 requests per minute, and then also 4 million tokens per minute. So when you break that down, that is, those 4 million tokens equate to basically passing 25 novels worth of English language text or 280 academic papers, or equally literally thousands of images. And it's that whole kind of processing power that Google's got behind the scenes really enables these kind of numbers and processing power, basically. Pricing is a really important one. So this is the input costs for tokens, to effectively input tokens per call. Now, back in the kind of start of things, when GPT-4 came out, you were looking at $36 per 1 million tokens. And so everyone was quite conscious as to what they were passing in for the likes of the OpenAI API to run, because it was actually quite expensive. But over the last couple of years, the prices have decreased exponentially, basically. Now, whilst, as I mentioned, it's not a like for comparison, Gemini Flash 1.5 Flash 8B is now at the point where it's incredibly cheap, just 3.75 cents per 1 million tokens. But of course, this continues to evolve. If you wanted to bring in the recently talked about model, DeepSeek, for example, utilizing the API for DeepSeek, you're talking usually around $0.27 per 1 million tokens. So again, the price to make calls to these models has dropped dramatically. And finally, the JSON mode and structured outputs that Christian was just mentioning is absolutely key for us as well, to be able to ensure that we get output from the models that we can actually ingest cleanly and FME can take in and utilize. We now have a user story, and I'm really pleased and grateful to UKPN that they're able to, or that they've allowed us to share the story today. We are currently undertaking within Avineon Tensing a very large project with them, digitizing their Eastern and London power network areas. And as part of this, they have an awfully large collection of service record cards, and these are quite historical cards. But to try and get you in the right frame of mind on this, I imagine you've seen or were completely bombarded by adverts at the moment for electric cars. Don't normally see adverts for the benefits of electricity in your home, but this was the type of advert you would see at the kind of dawn of the 20th century in London, which is remarkable. So now you've got the context of where I might be going with this. You'll start to see that UKPN has got an incredible backlog of records of electrical installations. So essentially, power that's been linked up from the road or nearby pathway into a property. And there are various different formats. Some are predominantly all handwritten, and quite remarkable how diverse these are, up until the early 1990s, where fortunately the advent of the dot matrix printer helped to add some standardization to these record cards. Now, the actual kind of requirement here from PN, United Kingdom Power Networks, was to review these cards and try and get a bit of a breakdown as to not only the ages of them, but also how many times each card had been modified or touched through time, because of course an electrical line can be modified over quite a long period. Here, for example, the request was to go through just over 1 million service record cards and extract out the dates from them, asking to extract out in a standard format like YMDD and put into a database. Now, I think you can start to think about how this kind of question came about at exactly the perfect time, because this is really at the point where all of those factors that really make that Gemini model so powerful kind of come into play. It got us thinking about how we could utilize that to undertake this process. So let me show you what we did within FME. We pulled in all of the data, or downloaded it rather, and unzipped it from an SFTP site. So these are all of the scanned images of the service cards. And then within FME, we basically logged all of those files, loaded them into an Azure queue. So effectively each service record card was a record within an Azure queue. We also created a complete list of all of the files and all of the records that we had. So literally just the file names principally. And we also moved those files from local storage into cloud storage. The reason we did this is because we wanted to make available the capability to parallelize this process. And Azure queues are really important for that, because what it means is that each process that's running concurrently takes a record or set of records at a time, and then no other process can pick those up. The actual process itself is actually relatively straightforward. In our case, with this Azure queue, 20 records were being picked up per second. Then within that record, you would have the URL to that file within Azure, and FME would help to construct the body of the post, which contained the image encoded within it, or images, in fact. Some cards were actually multiple pages. And then once the body was constructed, it was sent over to Google Gemini using the HTTP caller. And then the output was extracted out from JSON and loaded into a SQL DB. And of course, we had a number of these running in parallel, basically. Now, of course, there's always going to be some that fail or cause problems. So what we had to do was we had that initial table of all of the files that needed to be processed. And then obviously the tables which actually had the processed output. So using the feature joiner, we basically just added the remaining to an Azure queue to sweep up the remaining or outstanding service cards. So next, I'll just show you quickly what that looks like inside FME form, just running locally on the desktop. So here's the Azure storage connector. That's then going off to the Azure blob storage, where it picks up and encodes the file. And then it constructs the prompt. You get a bit of a brief preview of what that prompt looks like there. It goes off, makes the call to Google Gemini using the HTTP caller. And then with a little bit of JSON manipulation and string extraction, the dates and other components are written out into that table within SQL. Now to the results. We were able to process those 1.09 million cards within 26 hours. So we achieved a rate of about 700 per minute. Still far from the 4,000, but there's a few reasons we probably haven't got enough time to go into why we didn't quite get there, but we have in subsequent processes got higher numbers than that, but still really quite remarkable to be able to pass 700 requests to a generative AI model. The oldest card that we found was from the 9th of January 1907, which is actually shown on the screen, although not overly remarkable as a service card, but still quite nice that it picked that one up. Now, to move on to the kind of costs associated with this, I said that the Gemini 1.5 Flash 8B was the cheapest model, but what does that really mean? What does it look like in real terms? For this particular case, we were submitting about 2,900 tokens per request. So in total, for all of the records, we got up to almost 3.4 billion tokens used. That cost us in the Gemini billing or the Google billing £100. And in the output tokens, we used just under 23.5 million, which cost, £5.50 basically. Now, to think about this manually, if you could find somebody to do this and they were able to extract the dates out in that structured format in maybe 2 minutes per record card, working at it 8 hours a day, 240 working days a year, you're probably looking at about 19 years worth of effort to have undertaken this task. So it puts it in perspective that just without this type of solution, to get that kind of quick analysis on these cards is just impossible. So some learnings here. One of the things that was really interesting was the fact that if you input your prompt in JSON or maybe even pseudo JSON, you get a lot better response out of it. So this isn't the construct within the API. This is just the prompt itself. So specifying what data type it is and what format you're after had a really big impact on just the success of the output. The other thing is, you're probably familiar now with the chain of thought idea that DeepSeek has shown off. Google Gemini has their own through their flash thinking model. One thing that's awesome about this is you can pass images as well as text, which is an advantage over DeepSeek. And what it shows is the thinking process as it's going through to generate its response. So if, for example, you're not quite capturing components of images and data that you want to extract, you can give it some examples of where it's failing, and then it runs through a process and suggests ways in which you could probably improve the prompt. And by looking through its reasoning and the response, you can start to build up even better prompting, if that makes sense. So in the AI studio, have a look at the Flash thinking experimental model. It's quite good fun. And because things progress all the time, of course, as I was putting together this presentation, Gemini 2.0 came out under general availability. It is considerably stronger than Gemini 1.5 Flash in a range of different benchmarks. It is a little bit more expensive, 3 times more expensive, but still in real terms, compared to even 6 months ago, it's a remarkably good value. So definitely one to consider now. If I was to do this project again, we would be using the Gemini 2.0 Flash model. And indeed we are for some particular processes. One of which is, I wanted to show a comparison of Gemini 1.5 versus Gemini 2 for extraction of some of the addresses that we have within service cards, and also some of the properties that we have within some of the sketches that are drawn out for the service cards as well. So where this column's Gemini 1.5 and this is Gemini 2. So in a number of cases, Gemini 1.5 has failed to be able to extract out text from those service cards. Maybe the quality is a little bit poor, or just the handwriting was just too difficult for it to read. Whereas in Gemini 2, it's been able to pick up information. We've also found out that Gemini 2 model definitely seems to respect the prompts a little bit more. So one of the prompts was to ignore certain components or letters that are present within the template for some of these service cards, this A, B, C, D, E, F, and curb. So where the Gemini 1.5 model seemed to like to include it, we got much better results. They were always consistently excluded under the Gemini 2 model, which is really encouraging. Just a short mention of FME Hub transformers and the upcoming Skills Booster. We have a range of different transformers in the hub. We're a verified producer or author of a range of different transformers. There's 2 for Google Gemini that you can utilize, and all you really need to do is get a key from the Google AI Studio. One of them, which is a bit of fun, is the bounding box connector. I think we win the award for maybe the longest transformer name, which is a little bit daft. I'm sorry for that. But here it's hit and miss, to be honest, but it can be really very good at identifying and putting building boxes around objects in images. So definitely one to play with. And finally, the FME Skills Booster. So this is an event that we run where we provide a environment with FME already set up. So all you need is a browser, and we have a range of different templates and workflows to follow over the course of a 60-minute session, where we basically can show you how to use some of these AI transformers and get to grips with the technology. So if you want to register, it's free to register and to attend. Follow the link or scan the QR code. That next one is on the 4th of March at 11 a.m. And then also we are running something very similar at the UC. Yeah, a bit of a tag team, I think, between ourselves and Christian as well. So that should be a good event. And if you are going to the UC, feel free to register for that training as well. Thank you very much.
Awesome. Thank you, Oliver. That was fantastic. Yeah. And I really do encourage people to register for the booster. They're really great, and you'll learn a lot. I can guarantee you that.
Thank you.
Yeah. So thanks. Geez, just amazing demos from Josh and Chris and Oliver. I'm super excited. I can't wait to get my hands on some of this stuff as well and share these with people as I travel around. Really, really great. And I think for all of us in the technology space, this is moving so fast. Oliver built this whole thing, and then Google, and then Flash 2 comes out. Just a quick summary of the things we've seen. On the Google side, they shared a few workflows. One of them was using the high velocity data streaming of FME. So that's a capability of FME where it processes data as it arrives through a stream. In this case, they use a WebSocket connector, but it could be Kafka, it could be IBM MQ, it could be many different things. So that's a big use case of FME. They also used automations. So Josh talked about that. And it's always interesting to look at where FME users are thinking to expand the use. And Josh talked about the schema and value mapping, which fit really well into Christian's agentic schema mapping that uses AI agents to do the schema mapping on the fly, because it can be unpredictable what data Google's going to get, because of course the endpoints that are providing the data can change at any time. And then last but not least, of course, was Oliver, who just blew us all away on the power of what you can do with FME and Gemini. And one of the things that really stuck out for me was just how the AI prices are falling. And there's no reason to think that the prices aren't going to come down even farther. There's so many different AI technologies out there. And the one you use today could be different than the one you use tomorrow, or it could be task specific. And that's why at SAFE, we made the decision, you choose the AI you want to use, and we will make sure that we connect to it, hence the Any AI moniker. And a little bit about SAFE, if you've never heard about us, we've been working with data for 30 years. We have 25,000 organizations around the world that use us, over 200,000 users worldwide. And our community is really a great place to be, to learn and share. And of course, somewhere around the world, when we really want you to come to the peak of data and AI, because it's going to be a whole lot of fun and exciting. Yeah. Okay, Elizabeth, over to you. You're going to run through some resources.
Yes, thanks, Dawn. All right, so I just want to really drive home once again this free FME Skills Booster workshop that Oliver's team is offering. This is a great next step for you to take. And so we've got this QR code back up on the screen here in case you missed it on the earlier slides. That's this March 4th at 11 a.m. GMT. We hope you can make that. At SAFE, we are all about free resources. Definitely check out our FME Academy. We have free instructor-led training, guided learning at your fingertips as well through various resources in the knowledge base. And then we have our upcoming and on-demand webinars. Lots of great webinars coming up. Of course, our webinar on February 19th in about a week's time as well on AI agents. So we hope you can make that one as well.
Yeah, and we've done many webinars on AI, so that's just one top. So if you go to the on-demand, you'll see a lot of information there on many use cases. Every webinar we've done on AI, we make sure we have a user story so that it's real. It's not just us making stuff up. So yeah, really great.
All right, so in terms of next steps, we would encourage you to get in touch with us. We'd love to chat with you about anything, datainfo@safe.com. And then I've also plugged in Oliver's email here as well in case you have any follow-up questions for his team specifically. And then our FME Accelerator course, it's 90 minutes free of charge. I'd encourage you to take a look if you're getting started with FME. I personally took the course actually and found it to be very valuable, so I'd highly recommend.
Yeah, and you just show up. You don't have to install anything. It's all done through a browser, but you're actually working with the entire FME platform. So yeah, it's really easy to sign up and show up, and we get you going. Yeah.
Excellent. All right, if you are a member of our FME community, we have our community badge code here that you can redeem as a thank you for joining us today. And if you aren't a member of our community, we'd really encourage you to take a look at the community. It's a great place to both network with other users alike as well as experts there. Lots of engagement opportunities. I'll drop that link in the chat here as well so that you can copy and paste it. Once again, our peak of data and AI this May 6th to 8th in Seattle, Washington. We hope to see you there.
Yeah, it's going to be great.
It does look like we have 12 minutes remaining here for Q&A. We had some great questions come in, so thanks everyone for dropping those in. I'll invite Chris, Oliver, and Dawn to the stage here.
Yeah, I think, so I'll just say one thing. We actually highlighted the three major cloud vendors on this, so you might, in case you missed it. So we had AWS, we had Azure, and we had Google. I'll pass the first question off to Oliver. It's a good one from Areno Sun. All around, did UKPN pre-train a custom model? Yeah.
No, so that's just using the vanilla Gemini model. But what we did do was you're absolutely right. It's basically when we didn't get a response back, like a null result, we ran it through the Gemini 2 model. Now, at the time of running it, Gemini 2 wasn't kind of in general availability, so it had some kind of limitations on the number of calls you could make. But at least it was useful in showing that it was doing a much better job than 1.5. So now that it's under general availability, we're kind of basically rerunning it again for the ones that it missed, just to kind of help to mop up those ones that it missed out. But for the particular purposes of what we needed it to do, which was to get like a fairly good understanding of the age of those service cars through time, Gemini 1.5 was more than good enough. But yeah, that would be exactly, Reno-san is totally on point. That's exactly the way that you should approach it. I think start with the cheapest and then just build up to more powerful models. Although, to be honest, Gemini 2 is so cheap, it's not really such a worry. Just use that going forward.
Mm-hmm.
Yeah.
Mm-hmm. Yeah. So, Daniel, man, another one for you, Oliver. How are they using the data? Do you know what they're doing with it, or are you able to share that?
Yeah, a bit limited as to what I can share. But they are using it. It's all to kind of help support their understanding of the infrastructure and just general requirements on what's needed. So it's really an initial first pass understanding, just to really understand some of the scale of the works that they need to do in their modernization effort, basically.
Mm-hmm. Mm-hmm. Yeah. How about you, Christian? You see any that jump out?
There were a few on here around reporting on the validity of the results from the model. So that is actually a really good question and something that you can absolutely do with FME. I'm assuming with any process that you're currently doing for a manual equivalent, you would be reporting on something on the success metrics. So you'd potentially be sampling a certain number of features based on how many staff members are integrating these things. So I would say you could potentially do something very similar using another AI prompt if you would like, or you could simply just pull samples out of a batch of integration files that you'd be using and validate or audit those features as well. So you can do the exact same types of audits and reporting on the success or failures of these using the same tools that you have available to you in FME. Oliver, I'm not sure if you have any examples of any reporting use cases for any of the AI integrations that you've created already, but that's something that does come to mind for me.
Yeah, nothing that comes to mind at the moment. But yeah, it's definitely a good use case.
Yeah. I think the big takeaway with this one would be, obviously you're relying on one prompt to do a significant portion or uplift of this work or the process. So you can use a second prompt to do the exact same thing. You can use it to validate the results that you just got back from the first model. Of course, you can use a different service if you're getting better results from it. So for example, if you're using Gemini for the initial integration and cleansing, perhaps you're using OpenAI or DeepSeek or Llama for the next step to actually perform that validation. So you're not tied into one specific infrastructure or system or service. You can use whatever one is best fit for that specific task.
Yeah. The other thing I really liked about this webinar was both examples were data at scale, right? You have Google, who's building a worldwide data set, and then you have Oliver that's sending millions of scanned documents. So these are not toy examples by any stretch. These are like massive. And in Oliver's case, the cost is it's almost inconsequential. Like 110 pounds versus 19 years estimated of, manual labor. Just shows how AI makes new things possible, right? So yeah, really, really exciting. Somebody asked about data residency. And we'll follow up. Would you have anything on that one, Oliver?
So all of the API calls to Gemini are all over HTTPS. It's all kind of encrypted. The data itself is actually all hosted in Azure. So that's all kind of again stored and encrypted at rest. So for those types of things, it's protected. I mean, the other option is if you are obviously hesitant about moving stuff off-site, there's obviously options of being able to run models which are surprisingly powerful locally as well. So utilizing a Llama, and there's already a transformer to do that, right, Christian?
That's correct, yeah. And just to also expand on that, we're talking right now about sending data from your local machine or your local server to an online service. We didn't even touch on things called remote engine services. So we have the capabilities to have engines deployed in these data warehouses already. So if your data already resides in a specific warehouse, you can actually deploy an FME flow engine there. So it doesn't even have to leave the warehouse. It'll be processed in the same area. So as long as you've deployed your AI model or your AI service in that specific region, the data will be processed in the same spot. There will be no ingress or egress. So in terms of security, that is probably as tight as you could possibly be.
Mm-hmm.
Again, just harping on the flexibility of the FME platform, we're talking a lot about the actual specific tools or the transformers and readers that help you achieve this, but that's at the next level of the enterprise deployment where you have things available like remote engine services to support those security needs.
Yeah. Great. Any others? Yeah.
It looks like, I'm just scrolling through. We have a lot of questions, which is amazing. Looks like we've gotten to all the ones we can address live here.
Yeah. Good.
Yeah, so I think we're all wrapped up with questions. If you do have any questions, I'll just note, feel free to drop them into the questions tab. I'll keep things running a couple minutes after we wrap up. So if something pops to mind, don't hesitate, drop it in.
Yeah. And thanks, Oliver, so much for joining us. And we look forward to seeing Oliver will be at the Peak in Seattle. And as I mentioned, him and Christian will be joining me during the opening plenary to talk about, any AI and walk through a few things. And and reach out to us at any time you have any questions, join the community, send email info@safe, whatever. We're happy to answer questions, send you samples, and have you join us all on this AI journey. Definitely the beginning for all of us. So
absolutely. Yeah, huge thank you to all our presenters and Google and Avineon Tensing for all your time preparing this content. And yeah, we hope you all have a great rest of your day. If you do have a moment to fill out our survey, we really appreciate any feedback.
Yeah, thank you, Elizabeth and Chris. Yeah,
absolutely. Thank you all. Thank you for joining, and hope to see you at the Peak.
Yep.
Thank you very much.
Thank you.
Take care, everyone.